Hey everyone, welcome to Cassandra.Lunch number 40. Today, Rahul is out of office, so I'll be taking over going through the intro deck. So today's topic is going to be the Scylla Migrator and how we can use it for Cassandra data operations. I'll also be giving the presentation on that as well. I'm a junior engineer here at Anant. Currently, the only organizers we have are Rahul. Aku used to be an organizer and helping us put together, getting speakers and getting out all the blog and YouTube content, but he's heading back to school. But we are looking for other co-organizers. Essentially, you would help find speakers and sponsors in the Cassandra community. If you want to help out, you can reach out to rahul@anant.us. We're a part of a larger community called Data Community DC. And Data Community DC is actually made up of a whole lot different groups, generally around data, as you can imagine. And we also call ourselves DC2, Data Community DC. So what do we cover here? We cover things related to the Cassandra protocol. Cassandra generally has a couple different protocols. Generally, it's how nodes talk to each other and how clients talk to the nodes. Many different systems either implement both of those in some way, or at least the client part. Hopefully, we'll cover things like Scylla, Yugabyte, Cosmos, key spaces, and other technologies that can do Cassandra protocol. At this point, we're really fascinated with Cassandra and the ecosystem around Cassandra, as well as technologies such as Spark and Kafka, how they can work with Cassandra. At this point, generally, if we were in person, we would get up and talk to someone for a couple of minutes that we haven't talked to. But because we're in the Zoom environment, we can have someone new say hi, what brought them here, and what they hope to get out of this meetup. I'm just going to look through the participants list. It looks like Sunny. I think you're the only new person today. Would you like to say hi and what brought you here and what you hope to get out of this meetup?
Hey Arpan. Yeah, hi. My name is Sunny, and I'm also a Cassandra aspirant. I've been using Cassandra for around 2 years now. Apache Cassandra data stacks. Uh, we have it in our current environment. So just was curious to know what's on the plate here, and it's always good to hear from Rahul and from you, all you participants, to gain knowledge and expertise. Very interesting conversations, basically.
Great. Pleasure having you, and we hope you can make out for future events as well.
Thank you.
So group rules, if you have a question, ask it. Obviously be polite and courteous to others. And if you have some knowledge or some experience working with something that someone's giving the presentation on, go ahead and share because this is a community. And so the more each person knows, the more everyone knows. So depending on the speaker, sometimes they prefer you either ask questions at a break point, or you can just send your message in the chat and they'll get to it at a certain point in the presentation. Our company, Anant, we work with technologies related to global real-time and data. These generally surround Spark, Cassandra, and Kafka. So the technologies we cover in this meetup are kind of our daily life. DataStax is a partner and a sponsor. GW University has been a great supporter of Data Community DC, like providing venue space when we have in-person meetups. We also have some local and organizational sponsors in the DC area. This is a little section we have, see if anyone has any jobs or is looking for a job, if there's any upcoming events that they want to advertise. We will be doing a workshop with DataStax in a few weeks about how to migrate to the cloud from on-premise and what options there are for that. If anyone has any jobs, meetups, hackathons, etc., they can go ahead and speak up or they can leave it in the chat. Okay, looks like nothing. So these are some upcoming events we have. DataStax has weekly workshops. This specific meetup, Cassandra.Lunch, happens every Wednesday at 12 p.m. Eastern. We also have another lunch that we do called Data Engineers Lunch, and that covers just the whole general scope of data engineering, different tools, and that happens every Monday at noon Eastern. We have some upcoming topics that we might be talking about in the pipeline, such as things as like Airflow and Cassandra, Kubernetes and Cassandra, and Jenkins and Cassandra. Um, I believe, Obi, are you Cassandra.Lunch next week?
No, I have data engineers lunch, but I believe I have Cassandra lunch later in the month.
Okay, so I think Rahul has that. He might be covering one of these topics, or he might pick something else from the backlog. But be sure to be on the lookout for that. We'll update our meetup and Eventbrite items as well.
Hey, Arpan, is the Zoom link meeting the same for the lunch as this one?
Yes.
All right. Okay. Thank you.
Mhm. Okay. If you want to find all the old lunches, we didn't start recording till Cassandra.Lunch 10, but everything from Cassandra.Lunch 10 to current is available on our YouTube channel, youtube.com/AnantCorp. And there's a playlist with every single video there, again, starting from lunch number 10. And then we'll also like to shout out Cassandra.Link. It's a manually curated site with roughly about over 1,000 links related to Cassandra, and also things like Spark and Cassandra, or Kafka and Cassandra, or DataStax, etc. You can sign up for the newsletter if you want to get updates regarding Cassandra resources, and you can find that on the Cassandra.Link website. So now we will move on to today's topic, which is um, which is the Scylla Migrator and how we can use it for Cassandra data operations. So I'll go ahead and pull down this slide deck. Can everyone still see my screen?
Yeah, you're good.
Okay. So we will be covering the Scylla Migrator and how we can move Cassandra data with the Scylla Spark Migrator. If you're not familiar with the Scala Migrator, it's essentially an Apache Spark job that was built to migrate data extract from or using Spark to Scala, normally from Cassandra. If you're not familiar what Scala is, it's essentially it's a C++ built um, NoSQL database. It is open sourced, I believe, and I think it was designed to be compliant with Cassandra or compatible with Cassandra. It also has compatibility with Dynamo, I believe. In simple terms, the migrator works by generating a data frame from the source and then writing it to the destination. There is obviously more complex. There's more complexity in how it actually works, but that's just a simple layman's term of how it takes data from one source and puts it into the target or destination. The deep dive blog that Scylla has, it's linked in the slide deck, which will be available at least by tomorrow when this YouTube video goes up, but it'll also be available in the blog that goes up in addition to it. So they also utilize something called save points. So save points are essentially configuration files that are saved as the migrator runs, and that essentially tells the job as it's going to skip token ranges that have already been copied. And this configuration only applies when copying from Cassandra or Scylla. So the migrator itself has functionality for moving data from like Parquet and Dynamo, but we'll just be focusing on Cassandra and Scylla. Additional configurations can also be set and adjusted in the config.yml file. And we'll talk a little bit about that once we get to the demo portion. So for the demo portion, I have this GitHub repo. I will send it in the chat. And so essentially what this is, it's a fork of the actual like Scala Migrator repo. But the Scala Migrator repo itself is not pre-built, but when you use it, it is compiled. So you would need to run build sh on it. So I've already done that for you because the build takes a little bit of time. We want to respect everyone's time. So we just did it ahead of time. So essentially it uses SBT and assembly. So you can either SBT package or SBT assembly. So assembly makes a fat jar, which wraps all the dependencies in it. So technically, if you wanted to use the jar that I already have and use it for your own purposes, you can, because it has all the dependencies you need wrapped into it. And so essentially, we're going to use their Dockerized demo that they provide instructions for. So their demo originally is for moving data from Cassandra into Scylla, but we've modified it to show you how you can move data from Cassandra into another Cassandra container. And we'll walk through that as we go through the demo. And we will go ahead and get started with it. If anyone has any questions, they can go ahead and open up, or if they have any input they want to add, if they've worked with the Scala Migrator before, don't hesitate to speak up, because obviously, as I mentioned, the more you know, the more everyone knows. Okay. So I will be, just as a heads up, I have two screens. So I'll be copying commands from the GitHub repo. So you can follow along on the GitHub repo and as we go through the demo, just to see what I'm doing and the reason for it. But I'll be talking through it as we go along. Okay. So I'll go ahead and close this out. Can everyone see my terminal screen?
Yeah.
Yes, we can.
Great. So as I mentioned, we've bypassed some steps like running build.sh just to make this as fast as possible. So in the instructions of the original Scala Migrator repo, you can either run it on a live Spark cluster, or you can run it on like a local Docker example. If you want instructions for that, you can find it on the original repo. And if you further want to extend this current demo that we're using, if you're making code changes to the actual the Scala code, you would need to rebuild and reassemble the jar before those changes obviously are applicable. But essentially, we're just going to go ahead and clone this repo. And then we're just going to CD into it. All right. So first thing we're going to run is Docker compose up to get our containers started. All right. And so essentially what we're doing in this Docker compose is we're creating multiple containers. So this Cass1 is going to be our first Cassandra instance, our source. Spark master will be our Spark that we're going to be using when we run the migrator. This Cass2 is our destination Cassandra instance. And then they just, in their Docker compose file that they give you for the tutorial, they have one worker. And so we just used it. So we only modified certain things. So this was Cassandra, but this Cass2, which was the destination, was originally Scylla. So we made some configuration changes and modified the Docker compose file. And you can read that in the GitHub repo. All right. Okay, let me see. Promote asked to increase the font size. Let me see if I can. Not sure. Okay, view window. Let me see if I can.
Zoom is there in view.
Yeah. Okay, tell me when it's good. Is that good, Promote, or you still want me to go higher? Okay, cool. So I'm just going to do a quick clear on this. And then I'm just going to show the Docker thing. So we have this Docker, the entire service, and then we have 4 subcontainers running under it. So let me click on this so we can just look at the terminals. So we see Cass2 it's good to go. Let's look at Cass1. Cass1's also good to go. So if you run into 137 errors in Docker and one of these nodes or one of these containers doesn't start, you'll need to increase your memory resources. So I ran into that originally. So you would essentially just go into your settings and go to your resources. So my default was set as 2 gigs, but I was noticing that containers were essentially 137 out and were dying. And so I looked online and I found that if you increase the memory allocation to 4 gigs, it works perfectly fine for our specific purposes. So what we're going to do first is we're going to run a couple commands. So this first command is going to copy the source CQL file. And the source CQL file is essentially going to create, actually, let me pull this down. Put this on screen 3. So the source CQL file creates a key space. It uses demo, essentially just the key space we did. It creates a table and seeds it with 1,000 records. So this is going to be our source data that we're going to take and move into Cass2. So we're going to do the same exact thing for Cass2, but we're not going to seed it because that's what the migration is going to do for us. But an important thing to notice when you're using the Scala Migrator is you need to have the same exact schema. You can rename columns with the migrator, and we'll talk a little bit about that once we look at when we're editing our config.yml file. But essentially, so we did that for source. I'm going to move this back up so I can copy and paste it without leaving the screen. So now we're putting target.cql on Cass2, which is our destination. So now we're going to set up our source and target Cassandra containers. So we're going to open 2 new terminals. So the first terminal, we are going to access Cassandra.1 CQLSH with Docker compose execute. And so once we're in there, we can use the source command. And because we loaded it here, right? We loaded source.cql, we can just say source. And once it runs, we're just going to do use demo. And then we'll say describe tables. And we have that. So we'll just do a select. I already have this command written, so I'm just going to, whoops, let me exit, run that again. All right, so we have 1,000 rows in our Cass1 container, so our source container. So we're just going to open a new tab and do essentially the same thing, but this time we're going to do Cass2, which is our destination. We're going to open CQLSH, and then we're also going to run source, but again, because this is a destination, we're using target CQL, which only has the same exact steps minus the seeding. And then when we run a select count, we should get 0, which makes sense, right? So now we need to go back to the first terminal and we need to set up our config.yml file. So we're going to run a command to rename it. And then we're going to vim into it to make our edits. So the first thing we need to do is see here we have this source. We need to change the host to Cass1 because that is our source. Our key space is called demo, and our table is called spacecraft journey catalog. So there's other configurations you can set, like TTLs and write times, your split counts and connections and fetch size. And then you can also have optional conditions to filter with wheres. But we're just going to show you how to do this in a very basic manner. So we're not going to adjust any of this other stuff. We're just going to port from one and port it into another. So then if we go into the source or the destination section. So again, like I mentioned earlier, you can load from a Parquet. You can use Dynamo. But if we just keep scrolling down, we'll get to the target part. So it's in the option or in the example config that they provide, their type is Scylla. So we need to change this to Cassandra, and our host is going to be Cass2, right? Because that's our target container. And then again, we just need to change our key space to demo and our table to spacecraft journey catalog. And as I mentioned here, the destination table must have the same schema as the source table. If you would like to rename columns, you can do that, and you would just need to adjust it in the rename section. But essentially, again, there's more configurations you can do, like connections, but that's only for Scylla, I believe. And then you can do, let me scroll down to the renaming section. And here also, this is where you can set save points and the interval at which it happens. We don't need to change anything here, but one thing I would mention is we will see some save point errors when we run this demo, but we will still see the transfer work correctly. I haven't been able to debug why the save points aren't being created. But again, it doesn't affect our demo that we're doing right now. I think it might be, well, I won't dwell on it, but essentially columns, again, if you want to rename columns from source column name to destination column name, you would specify it. And then you can also additionally set skip token ranges. But again, the save points kind of already do that for you. And then they have this validation thing, but we don't necessarily need to use it. But essentially that's it. We're just going to WQ out of this. And so our config file is set. Now we can go ahead and run the Spark Migrator. So the Spark, the Spark master container will mount the target Scala 2.11 directory, and that's where, if you're familiar with SBT, when you run like package or assemble, it will put the jar file into that target directory. So the migrator automatically, or like the configurations they have set, and I think the Docker compose file, it mounts that target Scala directory onto the jars directory and the repository root onto app. So all you have to do when you get to the actual running the migrator is just copy and paste the command I have in the GitHub repo, because it'll run as expected. Again, if you want to make edits to the actual migrator code, you would need to use SBT and rerun build.sh, because that will essentially run SBT assembly for you. You can read that in the GitHub repository on the original one, or I think I have it on the fork, but yeah, you can go through the build.sh and see what's happening. But make sure you're back in this first terminal. So we're just going to do a quick confirm. So we still have 1,000 records in Cass1, which is our source container. And then if we go into Cass2, we still have 0 rows. So ideally what's going to happen is when we run this Spark job, it's going to move or copy the 1,000 rows from Cass1 and then essentially write them into Cass2. Like I mentioned earlier in the slide deck, in simple terms, the way the migrator works is it creates a data frame and then writes the data frame. Again, it's much more complex than that, but just as at a very basic level, it's generating a data frame and then writing the data frame from source into destination. So I'm just going to go ahead and copy the Spark job code and paste it. So essentially what's happening is running the Spark master, Spark submit, which is when you're running jobs, and then it's using the package, or at least the code package from the migrator, from the jar, and it's loaded the jars that we've set, because remember the Docker compose, I think, already sets it on, or like using the target and sets it on jars. So when we run this, we'll see the migrator pick up, or at least the Spark job pick up the schema of the first source, and then it'll read the schema of the destination, and then it'll start doing the writes. All right, so just like loaded config, we see Cass1 demo spacecraft journey. So again, here it is. It picks up the original schema loaded, and this is the write loaded. And if we scroll down, see I mentioned we have this save point issue. I haven't been able to debug it, but again, it doesn't affect this specific demo. So if I go into the Cass2 CQLSH terminal and I just keep rerunning the select count, we'll see it slowly build as the job is running. And we are at 1,000. So we have taken data from our, so actually I have to, let me pull up. So the unfortunate thing about this is if you try to kill the job in the terminal, it doesn't actually work. So you have to kill it from the Spark UI. So I'm just pulling that up on my second screen. All right, yep, master removed our application. So then if I go back to Cass1, which is our source, nothing changed because Spark picked it up, created a data frame. Again, in simple terms, created a data frame. It's doing much more under the hood. And then it took that data frame it created and wrote it into the destination. So we were able to kind of simulate using Docker containers. Obviously in the, I'm gonna close this real quick because we don't need that one anymore. I'm just gonna open the vim config.yml. So we used Cass1 and Cass2. Here we can use it this way because we created a network in the Docker Compose. However, you can use actual host points here. So if you want to do like your IPs from your source and your IP of your destination Cassandra clusters or Cassandra instances, you can do that. But again, for this specific demo, we just used our Docker container names. But essentially with this Docker tutorial, we simulated how we could potentially do this in a live Spark cluster or just using Docker to potentially do it. But yeah, that's about it and about how simple it is. Again, if you're running this for the first time by yourself from the original migrator, the build SH might take some time because it has to build a lot. But I think you can adjust it depending on, like if you want to take out the Dynamo stuff, I think you can, but you might need to adjust code in there. So again, that's, okay, Sunny's got to drop for a meeting. It was great having you, and we hope to see you again. All right, and back to this. So using the Docker container or the Docker containers, we were able kind of to simulate how we could potentially do this on a production or dev or QA cluster scenario. But again, that'll wrap it up. If anyone has any questions, you can direct them in the chat. Or if anyone has anything they would like to add, please feel free. Okay, looks like no questions. We'll go ahead and stop sharing. Again, I'd like to thank everyone for coming out to Cassandra.Lunch number 40. The YouTube video will be available at earliest tomorrow. There will also be a blog post with any resources and a slide deck that goes with it. And we hope to see you next week. Thank you.